Hey everybody, welcome back this week. We are talking this week about single project evaluation. We have 4 lectures this week, but most of them are pretty short. There is this one which talks about using net, future, and annual equivalent value methods for solving for project evaluation. This has an associated example in Excel that I encourage you to follow along with. And then there is also another method called internal rate of return, and that also has a Excel associated with that lecture. So there are 4 lectures. They're all pretty short. So far we have learned methods that help you estimate the equivalent value of cash flows at a given period of time. So what we want to do is use that to determine if a single project is acceptable, and then also use it to compare project alternatives amongst one another. So which one will have the highest value at a certain point in time, or if the project is feasible or not. So the net present worth method, if given a set of alternatives, determine the equivalent present worth of both alternatives or all alternatives, and then you can compare them directly. You have to use this. This is why the time value of money equations are important, is so that you can compare the value of projects at the same point in time or fairly. So the present worth is going to be equal to the sum of all of the cash flows at time 0. So what we need to do for this method is calculate the value of all the time flows or all the cash flows at time 0 and then compare them. So let's use an example. If given this cash flow diagram, we want to evaluate what the present worth of this project is. This is already at time 0, so we know that we have negative $750 there. And for the annuity here, it goes from 1, and you can see the N is 15 years, I is 3% per year. So the present equivalent value of that is going to be, using your time value of money equations, $75 times the present worth factor of the annuity. That is 11.9379, and we get that this annuity is equal to $895.34 in year 0. So present equivalent value is the negative $750 that we paid, and then the $895.34 annually that is earned from the project, and overall the net present value of that is $145.34. Future worth method and the annual worth methods are exactly the same, except instead of calculating the present value, you calculate the future value, or you calculate the annual worth of the project, and then again you can use that to compare them or determine, as long as they're positive, the project is economically justified. So the thing to remember with these is just to compare them all at the same time period. You can take all of the cash flows back to one time period and then compare them, or evaluate if the project is worth carrying out. That's really all there is to these methods. Let's do an example word problem. A large automobile manufacturer is considering the installation of a high-tech material handling system for $30 million. The system will save $7.5 million per year in manual labor and will incur operations and maintenance expenditures of $2.75 million. The salvage value of the system at the end of its 10-year life is $800,000, assuming a 10% discount rate, should the system be recommended for implementation. So what are the important values that this problem says? Well, the $30 million is the cost, savings of $7.5 million per year, and the expenditures of $2.75 million per year annually. The salvage value of the system is $800,000, 10-year life, and 10% discount rate. Put this into our variables. We've got P equals negative 30 million. A is going to be 7.5 million, and it's for 10 years. A2 is negative 2.75 million, also for 10 years. Final value of $800,000, 10 years, and 10% discount rate. So the present equivalent value of that is going to be our P, our present value, plus the value of A at a 10% discount rate for 10 years. So both these A's go over the same time period. So we're adding them together. They occur in the same increments and everything. So we can add those together. And then the F times P over F, again, 10%, and then discounted 10 years. So let's plug in our values. Negative 30 million for P. These are the two A's. Don't forget the signs. We paid negative $30 million. The A2 was a cost. This is an O&M cost. This is money saved in the system. And then we have to calculate or look this present factor up. Then the $800,000 for F. That's the salvage value. And again, we have to either calculate this or look it up. So these factors, if we use the appendix in the table, this is in the back of the book, 6.1446, and then this is 0.3855, and then this present value is negative $504,000 and negative $504,750. If this was confusing to you, please try and follow along with the textbook and actually doing the math instead of just watching me do it, because that might help clear some things up. So the decision rules. If the net present value or the future present value or the future value or the annual value are all greater than 0, the project is said to be justified and has more value than the alternative, which is usually the do nothing. Don't invest the money, just do nothing. If the end present value or future value or annual value is less than 0, the project is overpriced and not justified because you do not recoup those benefits in addition to extra costs. So cash flows often do not include social, moral, or religious aspects of a project. So if you see something that's operating at a negative net present value but has societal benefit that has not been quantified, maybe an example of this could be a transit project that has benefits to the transportation network because it takes traffic off the road and relieves traffic congestion. That could be a benefit and maybe a justification for operating at a negative net present value. This method also does not currently account for risk. So if you find that based on your calculations you are pretty close to 0, it is unlikely that your evaluation or decision rule will necessarily be correct. Things change and everything. That's something that we want you to remember throughout this class. So if your project is around, the net present value of your project is $50, that doesn't mean really anything. That doesn't tell you that you should definitely proceed with the project. It also doesn't tell you that you definitely should not proceed with the project. It really just means that you need to evaluate the project further and decide if you want to take a risk where a loss is possible. So there are some Excel functions. We're going to go more into these when you watch the Excel sheet, but we've got these 5 functions and we'll just go over these when we talk in Excel. So please go watch that and then watch the IRR lectures and have a good week.